the stresses or the normal stresses at point A, point B, and point D. And then after that, we are going to determine and find the orientation of the neutral axis. Okay, we're going to find the orientation of the neutral axis. So as you can see on this graph or on this diagram, we know where our y-axis on, we know where our x-axis on. And then from here, we realize that the structure, or before we make that statement, we are aware that we have a moment on the x-axis, right? We are aware there's a mz, okay, and then this is the moment vector, and then we are also aware there is a my, right? So this is your my, and this is your moment vector. Okay. So we are also make known that it's tilted 20 degrees. So this angle from here to here is our 20 degrees. Okay. So we know that theta is equal to positive 20 degrees. Why is it positive 20 degrees? Because theta is measured from where? From the z-axis. Okay, so it's positive 20 degrees. So from here, we can write our so not just that. So we know there's two components. So we know that the structure is under centric, symmetrical or unsymmetrical bending. Okay, we are aware of that, right? So the formula we're going to use is stress in the x direction is equal to my over Iyy multiplied by z minus by mz over Izz multiplied by y. Now, as I said, don't worry about the sign because we are going to use moment vector to help us resolve the sign. Now, this equation over here, okay, equation A, it is the true form. So this is indeed minus. But if you forget, don't worry, okay? We are going to use the moment vector, okay? So do not worry about the sign, okay? So the first thing we are going to do, we are going to find my, right? My is equal to m sine theta. So m is 10 times 10 to the power 3. Then sine, and we know theta is positive what? 20. Okay. So this will be equal to sine or 10 to the power 3 times by sine 20. Hold on, degree. So 10 to the power 3 times by sine 20 is equal to 3420. Okay, 3420. And then mz is equal to m cos theta. So it's 10 times 10 to the power 3 cos positive 20. So it's 93.9397. 97. I beg your pardon, Newton meter. So we now know our, is it Newton meter or pound inch? I do apologize. So what we have identified, we know our my, we know our mz. Next, we need to find what is our iyy and izz. Okay, so that is not difficult at all. So I'm going to teach you how to a method that I've used that you will not make so much mistake to find your second moment of area or to find your centroid. I've been teaching this course, this is about the 12th times. Students always have problem finding their second moment of area. Okay, so we are now going to find iyy. Okay, we're going to determine iyy. So when we say iyy, the axis of interest, right? The axis of interest is this axis, y-axis. So this is axis of interest. So when that is the case, this is the width, and this is the case, the perpendicular distance. This is the depth. Okay. So exactly where along y or on the z-axis where y intersect, I don't know. We have to check. Okay, you cannot say based on observation. You can't do that. Okay, so I'm going to call this our section 1 and section 2, and this is my datum. Okay, everything the datum will be on the left hand side. So we have our section. Okay, we have 1 and we have section 2. Okay, and then the next one, we are going to have our width and depth, right? So section 1, the width is what? 363, so 6 plus 2, 8. The depth is 2, so this is equal to 16. And then on section number 2, the width is 2, the depth is 4, so this is 8. Okay. Then the next one that I'm going to draw, or I'm going to write out, that will be, so it's along the z-axis, so that it will be the small z bar. So this small z bar is basically, some of you might, Eugene, where this small z bar, it is this distance. Okay, so this is our z1, and then the next one, this distance, this is our z2, small z1 and small z2. So small z1 is 2 divided by 2, it's going 1. Small z2 is 2 plus by 4 divided by 2, right? So 2 plus by 4 divided by 2, this is equal to 4. Okay. And then from here, we determine our WD Z bar. So this is 16, 8, 16, 24, 32. So this will be 8, 16 plus 8, this is 24, and this is 48. So our Z bar, or our big Z bar, is 48 over 24. So this is 2 inches from datum. So in fact, the orange line I drawn, this line is in fact our centroid. We did not know earlier, but now we know. Okay. So next we are going to determine IYY1 and IYY2. Okay. So IYY1, and I'm going to show you a method. that you will not make mistake. Okay. So before I do that, so IYY is equal to width depth cube over 12 plus by area bracket capital Z bar minus small z bar, and then the whole thing squared. I think my small z bar is not small enough. Okay. So I'm not going to look at a figure. I'm just going to look at the table. Okay. And because of how we have done our table, so IYY1, okay, and you will not make mistake if your table is correct. So without looking at the figure, I'm looking at the table now. So you have 8, 2 cube over 12 plus by 16 bracket 2 minus 1 squared. So this will be equal to 8 times 2 power 3 divided by 12 plus by 16. So the answer is 64 over 3 inches to power 4. So how about I know this number is I just focus on the table. Some of you will say, Eugene, what do you mean focus on the table? So I just look at the table and I can formulate the numbers for the second moment of area. So here you go, 8, right? Then the next one is 2 cube power 12. Then you just look at the value 16. Okay. And then you look at 2. And then you just plug in 1. And then you square. Okay. So by just looking at the table, you can calculate your second moment of area accurately. Okay. So the next one is IYY2. Again, I'm not looking at the figure. I'm looking at the table. Okay, so you have 2, 4, 3 over 12 plus by 8, 2 minus 4 squared. Okay, so this will be equal to 2 times by 4 power 3 divided by 12 plus by 8 times by 2 squared. The answer is 128 over 3. Okay, again, if I were to draw the arrows, okay, as I say, I've been doing this for unfortunately long time. Okay, so whenever I do this, I never make mistake, and I hope you all will follow this method and not relying on the book's equation. Okay, or how the book or how the answer scheme by the publisher is doing it. Okay, use this method. Very seldom I make mistake in finding my second moment of area, and also at the central. But you have to get the table right. The most important thing is you have to get the table right. There you go. Okay. So from here, you can calculate your IYY. Okay, from here we can calculate IYY. So IYY is equal to 64 over 3 plus by 128 over 3. So this is equal to 64 128 is equal to 64 inches to power 4. Okay, so we know that now. Okay. So now the next thing we have to do is we have now to determine IZZ. Okay, so now IZZ is more straightforward. I'll tell you why later on. So now we are interested to find IZZ. Okay, so IZZ axis is this axis that I'm going to sketch in orange. Okay, so this is the axis of interest now. Okay, so that's IZZ. So when you declare that, we now know that this is the width and the perpendicular geometry This is the depth. The formula is the same, but we now no need to find